My name is George Iliadis. I'm a front-end engineer at OPAP, and today we'll take a look at a brief presentation that I prepared for you called Budgeting JS for your end users. The reason that I chose JS to focus on today is because over the past decade, our front-end tooling started to shift more and more towards JavaScript. As a result, or a side effect if you may, more JavaScript ends up being sent to our users, and that has some consequences. But before we begin, some disclaimers. This is way too short of a presentation to get into actual technical web performance details. Please keep in mind that there is no one-size-fits-all solution, and there will always be exception and special case scenarios. Also, this is in no way, shape, or form a framework bashing presentation. So today we'll take a look at things through the eyes of the user, and we will focus on his device and his connection. And we will see why budgeting for JavaScript is key if you want a performance side. But before we begin, we need to understand why does performance matter. It is actually a well-known fact that websites that load fast and offer a good user experience have better customer conversion rates. The longer a site takes to load after the first couple of seconds, the smaller the chance we convert that user into a sale, thus leaving money on the table. So performance means more profits. I'll preface the presentation with this. JavaScript is like chocolate. It's great, it tastes good, it's some here and there, and everything's fine. Eat lots of it in a small amount of time, and bad things will happen. Out of all the things we can give a browser, HTML, CSS, fonts, images, JavaScript is byte per byte the most expensive. That's because not only JavaScript is one of the slowest to process, but mainly it's a blocker. When JavaScript enters the picture inside a browser, everything else stops, right? You don't do any HTML or CSS parsing. There's no rendering jobs going on or drawing. You have to wait for it to finish. And those waiting costs add up. The more JavaScript you have, the more processing happens. And the more processing that happens, the longer everything else is blocked. That leads to bad times to interactive and poor lighthouse scores and bad SEO and less profits. But since JavaScript is so bad, why not skip it entirely, right? We can always go back to serving static sites and do form submissions like we used to. The reality, though, is quite different, right? Though JavaScript is the most expensive, it's also the most useful one. With just a few kilobytes, we could have DOM and CSS manipulation, data fetching, states, sockets, server-sent events, dynamic page transitions, access to local memory. But more importantly, JavaScript makes our sites functional, and it also makes the user experience better. So balance is needed. So let's break what actually makes JavaScript expensive. There are two pillars. The first one is the network cost. The network cost is not only the download time for a file, but it also comes with a financial cost for a user. For those of us who live in Greece, we know that we have some of the most expensive data plans across Europe, so every megabyte is paid for. The network cost goes up when we serve large amounts of JavaScript. Whenever we're serving JavaScript for things that are not needed, whenever we're serving JavaScript for things that we shouldn't, like JS and CSS client-side, CSS and JS, sorry. Whenever we're not breaking our bundles into small pieces, allowing for better parallelization or helping the browser to cache things. Or incorrectly loading scripts. You might have a script that's relevant to the bottom of your page. If you load it up front, you need to wait. Also, there are the post-download costs. Those are the costs that happen after you have downloaded JavaScript to your device. Those costs typically are the memory cost, the parsing cost, compiling and execution and main thread blocking costs, as we said earlier, but also poorly written code. We've all done that. Some of us still do. But how do those actually affect the user? Let's take a look at the user's connections. Despite the rapid rise of 5G networks, most of the globe is still on 3 and 4G networks. Do not get fooled by our Western standards, right? The African continent is largely on 3 and 4G. Same goes for South America and Asia. Countries like India, Pakistan, China, those are huge markets of people. And you would be a fool to skip on them, especially if you have an international product. But at the same time, you would say, I can see on the chart you're presenting that 5G is rising rapidly. Maybe just wait it out a year or two. Well, the reality is that even though 5G could be everywhere by tomorrow, most users wouldn't have a phone capable of taking advantage of that network. In 2021, just about 8% of the population had a 5G capable phone. In 2022, that number rose to 13% globally. So let's not assume equal access to the internet for everyone. But now let's talk at the users and their phones and their processing power. We can see that the processing ability of a phone rapidly drops with its price. The modern expensive premiums, the iPhones and the Samsung Galaxy that many of us are used to, offer great processing power. But that processing power, as we can see, rapidly declines as we follow those price points downwards. Also keep in mind, please, that 180 euros is not the actual bottom price for a phone. There are much more cheaper phones, but it was actually so hard to find stats for those, just a reflection of our attitude towards the less financially fortunate. But there are two catches here, right? One is that we need to keep in mind that the average device sold for 300 to 350 euro over the past years. And that's the average, meaning that 50% of the population had an even cheaper phone than that. So working with average just won't cut it. We need to go further down. A second catch is that we also need to realize that those are all new phones. The average user tends to keep their phone for 3.3 to 4 years. And things like cooling ability and battery charge decline, which both affect processing performance. That means that we're taking a user that not only has a weak phone from 3 years ago, but it's also old and beat up and worn. Now that we have seen what our users' devices and connection looks like, let's see what we have been serving to them. In 2019, the median website used to serve 360 kilobytes of JavaScript. Over a 4G network, that translates to 9 seconds to interactive. 9 seconds, right? After the first couple of seconds, you're already losing customers. And the fully loaded site is somewhere around 20. But you might notice that I said 2019. Are you fooling us here? Haven't things improved? Well, the reality is that no. Over the past couple of years, we have increased the JavaScript we are sending on users. We're currently serving 550K. And not only that, as you can notice, both our upper and bottom limits have also gone upwards as well. You might say, what are you talking about, dude? 550 is a lot? Then what should we aim for? Well, here's a quote from someone who is actually an authority on the matter, since he actually works and builds browsers. He usually puts budgeting goals for the web, and this one is for this year. The quote reads, to serve the users at the 75th percentile, P75 of devices and networks, we can now afford 150 kilobytes of HTML, CSS, and fonts, and 3 to 350 kilobytes of JavaScript compressed. For those of you curious about the P75 user, he's 1/3 on the way on the upward slope on the bell curve, right? Because averages, I'll say this again, are vanity metrics. You should be a little more inclusive. One more thing that I would like to point out here is that those two stacks of kilobytes are not equal. 1 kilobyte of JavaScript is, as we described earlier, is much more expensive than 1 kilobyte of HTML or CSS. So the ratio isn't 1-to-1, it's somewhere 1-to-5. So if you were to move that around, it would look much less on the other side. The reality, though, is that I can talk all I want and present stats and graphs about JavaScript, talk about budgeting, but it actually means nothing, right? The proof is in the pudding, and we should always test in actual user scenarios. So what I'll show you in a bit is an actual demonstration taken from my favorite article of all time regarding web performance, and it's the one that put me on this performance journey, if you will. And this is the work of a guy called Taylor Hunt, who worked at Kroger, a large retail chain in the US. What he did is that he noticed that their SPA site that was in production was quite slow. And he wrote those budgets the same way I did. He actually read an earlier budget, which was even smaller, and he did the math. He kept some business critical scripts, and he realized that he had 20 kilobytes total to make his site. 20 kilobytes, right? That's quite little, but the MATLAB did it. So, give me a second, please. So what you are about to see from left to right is the POC that he built versus their production application versus their native app, and he compared to two of their biggest competitors, Amazon and Walmart. And it's an actual test, right? He launches the website, he logs in, he searches for a product, he adds it to his cart, he goes to his cart, and he proceeds to the checkout. A very common user story for a commerce site. And he did it on a $100 phone on a 3G throttled connection. So this is as slow as it gets. I'll just play the first few seconds of it, just to realize. Already his site is loading. He's already searched for the app. The native app is still loading. Amazon is doing quite a good job, to be honest. They use plain JavaScript and they minimize that as much as possible. And it's already done. 20 seconds. As we can see on the bottom, this is quite a long video. Let me just go towards the end, just show you the times. It should finish somewhere around now. So 20 seconds versus 1 minute and 120 seconds of the native app versus 3 minutes and 44 seconds. That's a huge improvement. And all that was done just by budgeting his JavaScript. He decided that he needs to cut down on it and it could improve performance. Right, but this is my last slide. Unfortunately, this is quite a quick talk. And I know that I bombarded you in a very small amount of time with a lot of information, but if there is anything for you to take away from this presentation is this one. Please remember that we're building for the World Wide Web and not for the wealthy Western web. That's all, guys, from me. Thank you very much. I'm George Iliadis. And, you know, happy to discuss with any of you. I don't know if we could do a quick Q&A now, else I'll be down by our booth. You're welcome to come and have a chat with me. Those who agree, those who are neutral, but especially those who disagree. Thank you.